Hello guys, how are you? This is Hans Hawiya once again. We are continuing with our topic. In this lesson, we're going to look at plotting and interpreting motion graphs. We'll look at two types of graphs: distance time graphs and speed time graphs. But the question is, why graphs? Well, here's the answer. Well, this graph shows weight gain. This is weight gain plotted against the time in months. This is the follow-up period in months. So what do we see? This is the change in weight, right? This is change in weight. And here we have plotted weight gain versus time in months every 2 months, right? Every 2 months. So what do we see? We see that from the beginning, when we started, this is where the change came to, right? Then from there it was 30, then somewhere between 30 and 35 we can say 33, then here 24, and here 34, then 36, around 36, then somewhere around 32, then it went down, the change in weight went down. It was somewhere around 17 where it started, then it went below 15, which is 13, then it maintained 13 for the 10th month. Then before it went up to 38. So looking at this graph, really, we can tell what was happening. We can tell. Supposing this graph shows your weight, maybe you want to lose weight or maybe you want to gain weight, but you can clearly tell what was happening to your weight. Maybe also looking at the months here, maybe for the past 2 months, this is what happened. This is the second month, the 4th month, the 6th month, the 8th month, the 10th month, the 12th month, right? So from the 10th to the 12th month, we see the change is really big. It's really huge. There's a huge change in weight. So by just looking, you can tell that between the 10th and the 12th month, something went up, something was going on. If you didn't want to gain weight, you wanted to lose weight, you can maybe look at the kind of lifestyle you were living. Maybe you were eating too much junk foods, maybe you were not hitting the gym, then you can easily tell. But in opposite to what we see here, 17, this is weight gain, right? 17, 31, 33, 24, 34, 36, 32, 17, 13, 13, 38. By looking at the numbers, you can't really see from a glance that that something is going on maybe between the months here. You can't tell really, but when there is a visual representation, you can easily tell. Even the newly born baby, they have a card that tracks their weight, right? Tracks their weight against the month, or even their growth, because the doctors want to see if the baby is growing well or is the baby gaining enough weight. And when the baby may be sick, they can easily tell from that graph that no, between these months, the baby was not gaining weight. So they can easily tell. So that's the purpose of a graph. It gives a visual representation, which makes it easy to understand what is going on. And nowadays, a lot of people are into Forex, and you know that Forex deals with those graphs. They show you. Imagine if they gave you that data in like values, so many values. How many people will really tell the pattern? Can you tell the pattern from these numbers? from 17 here up to 18 here. Can you really tell the pattern, what was happening? And here we have few numbers. Numbers can be a lot of them. There can be a lot of numbers. So a visual representation, it gives us a picture. And remember, they say a picture is worth 1,000 words. So a picture really it makes things easy for analysis purposes and understanding purposes. Okay, so let's go on and look at motion graphs, and we'll start with distance time graphs. Well, here is an example of a distance time graph. We have drawn two of them. Okay, what we really want to do here is to look at the slope. We have to look at the slope. The slope is called a gradient. And this is how you calculate a gradient. Gradient or slope. Gradient is equal to change in y minus change in x. x1 minus x2. So in other words, we can just say G is equal to y1 minus y2 all over x1 minus x2. So the gradient is the slope. This is the slope. Let me put it in brackets. This is the slope of the graph. This is the slope of the graph. So what we want to do here, we want to calculate the slope before maybe we interpret the graphs, because we are going to relate to the gradient every time. We're going to be talking about the gradient of the graph, the slope of the graph, right? And what it means, what is it? So here we are going to have 0 here. This is time in seconds. Just a sketch. Supposing the value here is 5. Let it be 5. And then here, I hope this is nearly straight. Suppose here is 10, which is 10 meters. This is y. This is y-axis. This is x. This is y-axis. This is x-axis. Right? We want to calculate the slope for both of these graphs, right? So for this one, the first one, G is equal to y1 minus y2 over x1 minus x2. But we don't have x1, we don't have x2. I'm going to go on and I have 1 and 2, point 1 and point 2, to make my life easier. Okay, I'll call this point 1. I'll call it point 1. And I'll call this point 2. I should have used a different color, but that's okay. 2, right? That's point 2. That's point 2. Well, that's okay. We are going to subtract a smaller number from a bigger number. No, that's okay. No problem at all. No problem at all. But you can also do it this way. I'm also going to do it this way. y2 minus y1 over x2 minus y1. If it's y1 first, it's going to be x2 first. Okay? Yeah. So y1, what is the value of y at point 1? The y values are along this line, right? So the value of y here is 0. 0. Let me put brackets. Minus y2. What is the value of y at point 2? Where is point 2? Here is point 2. What is the value of y? The value of y is 10. So this is 10. And what are the units on the y-axis? This is m. This is all multiplied by m, because these are the units, right? Good. Then x1 minus x2. What is the value of x at point 1? This is point 1. What is the value of x here? 0. Minus, what is the x2? What is the value of x at point 2? This is point 2. The value of x is vertically downwards. This is 5. 5. And what are the units? These are the units. S. Right? S for seconds. Then, go on, what do we get? Let me change the color because the space is also small. Then 0 minus 10, that's negative 10 meters. This is meters. Then everything divided by 0 minus 5, that's negative 5. Negative 5 seconds, right? And then if we divide a negative value by a negative value, it becomes positive. It becomes positive, right? It becomes positive. Then that means this is 10 meters divided by 5 seconds. Then this is equal to 2 meters per second. And what is 2 meters per second? 2 meters per second, it comes out to be the speed. This is the speed. This is the speed. This is the speed. This is the speed. And what do we say? We conclude that the gradient of a displacement or distance time graph gives the speed or velocity. Right? That's it. That's the gradient of a distance time graph. So that's the gradient for this distance time graph. It is the speed, right? Then let's look at the second graph. Let's choose values once again. Let's choose, let me change the color to black. Let's choose, say this is 20, 0, and we can choose some value here, just sketching, and then let's choose any value here. Let's choose 10, right? Then we are to calculate the gradient, once again the slope. By inspection, we can actually see there is no slope. If you were walking on a road like this, being flat like this, it is not slopey, my friend. There is no slope, zero slope. But anyway, let's just calculate and see what we get. I'll choose this point to be 2 this time around, and choose this one to be my point 1, and then put in the brackets. Then let's calculate it. You can just calculate here. G is equal to y2. The other time it was y1. Yes, y2 minus y1 divided by x2 minus x1. Therefore, this will be y2 point of y at, value of y at point 2 is 20. This is 20 minus y1, value of y at point 1. At point 1, the value of y is still 20. No change at all. Divided by, remember, this is in meters. Divided by x2 minus x1, the value of x2. The value of x2. So what are we going to do? The value of x at point 2. What do we see? This is 0 minus x1, the value of x at point 1, here is point 1. The values of x on the x-axis, this is 10 m. Oh, not m really. This is s. Right? This is s. Remember, we get the units here, time in seconds. So these are seconds. Then we can come down to here. G is equal to 20 minus 20 is 0 meters divided by 0 minus 10 is negative 10 seconds. So the value of G is 0 meters per seconds. So the value of G is 0 meters per second, which means this is the what? This is the speed. The speed is 0. When the speed is 0, the object is not moving. The object is not moving because we have said the gradient of a distance time represent what? The speed. We don't just memorize it, we can work it out, and we come out with the units for speed. Okay, let's now look at the common graphs for distance time and interpret them, describe them. Okay, well, here we're saying when interpreting graphs, it is crucial to calculate the slope or gradient, where gradient is changing y-axis over changing x-axis. The formula is here, we've already established that. So let's look at distance time graphs and describe them. Well, what it really means here is at this point, this time is 0, right? This is the beginning. This could be 100 meters. And then at this point, time could be 2 seconds. And the distance is still 100. At this point, this could be 4 seconds. The distance is still 100. This could be at t is equal to 10 seconds, but the distance is still 100. This is the distance between the observer and the object in question, right? So the distance hasn't changed. Like maybe when you are sitting in your classroom, the board or maybe one student in your class hasn't moved the entire time. They have been 3 meters away from your desk for the entire 8 minutes. So according to you, that student is not moving. The student is stationary. In physics, we say the object is at rest. Object at rest, or you can just say the object is not moving. Object at rest. We say the object is at rest when a graph is a horizontal line and it's a distance time graph. So don't mix this with speed time graphs, I beg you. Let us also look at these distance time graphs and describe the motion of the object shown by the graph. Okay, for this one, we see that the slope is constant. The slope is not changing, right? The slope is not changing, is the same throughout. And we see that the distance is increasing as time goes by. So because the slope is constant, we say the speed is constant. Well, here are other typical distance time graphs that we need to describe. Well, for the first graph, we see that the gradient is not changing. The gradient is uniform. The gradient is uniform. It's not changing. The slope is the same. The slope is the same as time goes by. The distance is increasing. the distance covered is increasing. So because we know now that the gradient or the slope for distance time graph represent the speed, we can describe the motion of this object shown by this graph as constant speed. So the object is moving at a constant or uniform speed. Constant or uniform, constant speed graph, constant speed. The motion of the object is moving at a constant speed. So next one, let's look at this one. You can call this A, this B, then this one C. What do we notice about this graph? What we notice is the slope is increasing. The slope is increasing because at this point, if you are climbing maybe say a mountain like this, you'll notice that it will be easier to climb this mountain at point A than to climb it at B. So at B it's a little bit harder. So in that case, we see that the slope is increasing. The slope represents what? The speed. So therefore, the speed is increasing. The speed is increasing. Increasing speeds. Increasing speed. Good, that's it. Then if we look at this one, the slope here is decreasing. At this point, it's hard to climb this slope. If it were a slope that you can climb, maybe a mountain, like I've just said. So at B, we see that it's becoming a little bit easier. And we can predict that after that, it will be zero slope. It will be a horizontal line. So it's difficult here, it's easier at B. So this slope is decreasing. The slope or the gradient represent what? The speed. Therefore, speed is decreasing. Decreasing speed, right? Decreasing speed. Decreasing speed. That's it. Well, here is the hint that I want to leave you with. If you are really confused as to what does the slope represent in a distance time, because you're going to look at speed time, you might get confused a little bit. But if you look at distance over time, distance over time will always give you what? Speed. That's speed, my friends. That's speed. So by looking at distance over time, you can remember that distance over time gives you speed. So what you get here is the what? Is the slope. Under speed time, it will be speed and time, or velocity and time. Velocity over time gives you what? Acceleration. So those are the two slopes that you're going to be looking at. The slope which comes out to be the speed, and the slope which comes out to be acceleration. Those are the only two, so don't confuse them. Well, that's enough with distance time. In our next lesson, we'll look at velocity time or speed time graphs. Thank you.